Hello friends, welcome back to Qgis Basics. In this video today we will learn how to find out dangles in our linear data. So if we check here, this is our dangle, and if I zoom it here, this is also a dangle here. So how to find out these dangles? I had done this query. It already finds these. At these points there is a dangle. So how to ignore this problem, and I'll tell you how we can solve this problem. So let's get start the video. We will work on these two linear layers. We will choose method of graphical modeler. We will design a model for finding of dangles. So in graphical model there are two things which we consider: input and algorithm. Input for the to import a layer in 3D model, and algorithm is for processing of that layer. So first get start, add these two layers. These are the vector layers. So just drag it here, name it layer 1, its geometry type line. Okay, add another layer, layer 2, it's also a geometry type line, and uncheck this mandatory box. If we have one layer only to find angles, then it will work on single layer, and if we have two layers, then we have to select the second layer also. So click OK. Now we have these two layers, and now add the extent of the map you have opened. Click on extent, drag it here, click on map extent. Okay, if I try to run this, it will show me these two things: layer 1, layer 2, and map extent. If I click here, and it will give me the other options for map extent. So it's working fine here. Now add the processing to these layers. First we add a extent, and now convert this extent to polygon. Map extent is calculated in a polygon type. So just in algorithm, type create layer from extent, create layer from extent, drag it here, and its model input is from map extent. Click here. Now we have created a layer from this map extent in polygon. Now convert this polygon to line. Just search for polygon to line, and take the input as algorithm input, and extent from which we have created, create layer from extent, and okay. Now this polygon from here is converted into lines. Now create a buffer of this line. I'll tell you further why I am creating the buffer of this line. So just search buffer. We'll have buffer here. Now buffer input layer is algorithm, and polygon to lines, and distance is 1 meter, and click OK. Now we have buffer here. Now come to these two layers, and I'll just first, if you have large data, then you have to process this full functionality on whole data, but I don't have so much time, so I'll only process the extend data. So I will clip this data to my map extend, and then after that I'll process these layers. So first clip these two layers with extend, type clip and click here. Input layer is layer 1 and overlay layer is algorithm, which is create layer from extend, and name it clip layer 1. This layer is clipped here. Now clip second layer, layer 2, overlay is algorithm, and this is extend. Name it clip layer 2. Now I will merge these layers, merge these layers to a single line. Just search for merge vector layer, merge vector layers. I'll merge these two layers. So select input is clip layer 1, clip layer 2. Okay, now these two layers are merged in a single line. Now I'll create a refactor ID for this. Search for refactor. I'll organize this in a single column layer, and refactor ID input is algorithm output, that is merged layer, and here I'll add @row underscore number. New field name is FID. You can name it anything else also, and length is 11. Click OK. Now I'll get refactor field from here. Now I'll extract these vertices from this layer. So type extract vertices. I'll type extract specific vertices, and input layer is algorithm, that is our refactored layer, and our vertex indices are 0 and -1. 0 is for starting point and minus is for end point. So these two vertices are extracted by this 0 and 1. I'll rename this refactor as refactor field for FID. We will use further another refactor, so we'll rename that to other name also. Now we get vertices, and I'll find intersection of these lines. Search for intersection. So we'll here get line intersection. Input layer is refactor, and another is refactor only. Okay, and click line intersection. Okay, now we have line intersection and vertices. We will find the difference of these two intersection and vertices point. So search for difference, drag it here. Input layer is one is algorithm input, overlay also in algorithm, and we will have an specific vertices, and another one is intersection. And okay, here we will get difference. Name it as a difference dangles. Now come to this part. When we clip this layer from map extent, the last clipped line, the last point for clip line is also generated angle, so we have to remove those dangles from the extent area. So just we have created a buffer line. Now we'll find a difference of dangles from buffer line. So our input layer is algorithm and overlay is algorithm. So first one is difference dangles and second one is buffer algorithm. This is this buffer line algorithm, and okay, we will get difference removes from border. So these are the points which are removed using this from border areas. Now we will generate a refactor ID for this. So search for refactor. I'll create a refactor for this difference, and it's algorithm input, and it's a buffer difference remove from border, and add a the rate row number. New field name is buffer underscore ID and decimals 11. Okay, now we have the refactor ID here. For name it refactor field buffer, so it can differentiate from this refactor and buffer refactor. Now we will create a buffer on these dangles which are created till this point. So create another buffer with the given tolerance. I want to give a tolerance for this. So input layer is our algorithm input, that is refactor field buffer, and our tolerance field is we have to input it manually, so we will add a number field for this. Go to input and we will add number for this. I'll keep it here. This work as a tolerance. It's float, value is 0.01, maximum is 100, default value I'll keep it 25. This is in meter. So this is our input for tolerance. Now I'll change this setting and distance to model input tolerance, and okay, now we have tolerance from this input layer, and we will get here buffer dangles. We will get buffer dangles here. Now I'll join these dangles which received from here, from refactor ID and from this dangle. So on algorithm, join by attribute, join attribute by location summary, and first one is our algorithm input, that is buffer dangle, and feature is intersect by comparing it our first dangles, which first intersections which we have created with refactor IDs. So algorithm input, and it is refactor FID. Okay, and our calculation options is to count. Okay, now we have our attributes. Well, now we have joined our attributes by locations using count. Now I'll extract the attributes, extract attributes, search here, it will come down. Extract by attribute, and input is our algorithm input, that is join layer, and here we will select FID underscore count, which we will get from join layers. It should be greater than equal to 1. We will get our dangles using this. Now generate the centroid, and input is algorithm, and extract by attributes, matching attributes. Okay, and for every part, yes. Okay, this is our centroid, and L, and name it as dangles overshoot undershoot. Okay, now we will get a layer here. Save it. Dangle remover. Save it. You can name it here. You can name it group, topology group, and name is dangle remover. Once while you add this to processing, it will go as under topology group. Now try to run this. We will select layer 1 line 1, layer 2 line 2, and our map extent tolerance default is 25. Click on run. Close it, and here you will see we have all the dangles. So let's get correct one of the dangle. It's on line 2. Just edit it, and if I activate the snapping toolbar, but it doesn't have any vertices here. So first create a vertex on line 1, and created a vertex here. Now move the line 2 to this point. Now our line dangles corrected, and remember this point, we have dangles here. If I run it again, remove these dangles. I corrected this point, so next time I'll run, it will not come here. Now run, select line 1, select line 2, click on map extent tolerance, and click on run. Now we'll check. Now we don't have any dangle here which we have corrected. So this is the method. If you want to add this in processing toolbox, then click here, add model to toolbox, and click here, select your model. Now it's come here. Model name comes here. It's under topology. tool. So just close this, close all models, add open. Now if you open it again, then you will find it here only. No need to go to processing graphic modeler or open from here. So you will get from here. So that's all in this video. If you haven't subscribed, please subscribe this channel for getting these videos about QGIS. So thank you for watching.